Starting today. Right?
Yes. All right. Thank you all for coming to yet another episode of Remote High Energy Division Lunch Talks. And our first speaker is Fabio Pacucci, who many of you should already know. Fabio is currently a Black Hole Institute and Clay Fellow at the CFA and at the Black Hole Initiative. And he received his PhD in physics at the Scuola Normale Superiore in Pisa, Italy in 2016. After that, he spent some years at Yale University as a postdoc. His research focuses on the theory of formation, growth, and observational properties of the first population of black holes formed in the universe, as well as high redshift quasars. And today he'll be talking about separating accretion and mergers in the cosmic growth of black holes with X-ray and gravity observations.
All right. Thank you. Thank you very much for the introduction, and thank you for, yes.
Sorry to interrupt 1 second before we just wanted to mention, as with previous weeks, we will be ringing this bell at about 3 minutes to go. We couldn't figure out a more like a visual way of showing speakers how much time is left. Wasn't working on Zoom, so at the 3-minute mark. Sorry, please.
All right, sounds good. So thank you for the introduction and for giving me the opportunity to talk at the High Energy Phenomena Seminar. So today I will be briefly describing a new model that we developed to study the cosmic growth of black holes. So today's talk will revolve around two themes. So the first theme is the study of the main growth channel, so accretion versus mergers for black holes as a function of the black hole mass and as a function of the redshift. And then at the end, I will describe how this view could be changed by a possibly undetected population of high redshift quasars. And we call this possibly undetected population of quasars phantom quasars for the reasons that I hope you will understand towards the end of the talk. So we all know here that black holes come of all sizes in this chart. You can see that stellar mass black holes are, depending on the definition, up to 100 solar masses. And then we can reach the supermassive black hole stage up to some 10 billion solar masses. So they span about 10 orders of magnitude in mass. Of course, in order to reach this variety of masses, they need to grow, and they can grow via accretion or via mergers. So how do we compute the mass growth rates for our model? Of course, I don't have time to go into the details of the model now, but if you have some doubts, please ask me later. So regarding gas accretion, we model gas accretion, so the mass added via accretion, from quasar luminosity functions. And this is the Sultan argument, the classical Sultan argument. So using the quasar luminosity function and extrapolating whenever data is unavailable so far. Regarding mergers, we calculate the mass added via merger tree approach with some assumptions, of course, regarding the black hole seeding. So how many black holes and what's the typical mass of black holes that is created around redshift 15 or 20. Then the closed pair formation probability for mergers. Not all black holes merge with each other when their hosts merge. And also the energy released via gravitational waves. So this is the main plot that I will describe now step by step. On the horizontal axis here, you see the log of the black hole mass from 1,000 to 10 billion solar masses. On the vertical axis, you see the redshift, so basically the cosmic time from the local universe to the farthest galaxies discovered so far. So regarding the color bar on the right, wherever you see blue shades, it means that black holes are mostly adding mass via gas accretion and not via mergers. Instead, the opposite occurs when you see red shades. So these dot dashed lines instead indicates where we expect that accretion and mergers are equal to each other in contribution to the black hole growth. So here, for example, at low mass and low redshift, we expect that most of the black holes are accreting mass, while going to higher black hole masses, we expect that most of the mass is added via mergers. And instead, in the high redshift universe, we expect with a mix of seeding, so light seeds and high mass seeds, as I will explain in more broader terms later, we expect the opposite to occur. And this is basically summarized in this beautiful illustration that was done by Melissa Weiss here at the CFA, actually. So in the nearby universe, we expect that smaller black holes mostly grow via accretion, and larger black holes mostly grow via mergers. And in the distant universe, we expect the opposite to occur. So the question is, why do we care about what's the main growth channel? Well, we do care because that determines how we're going to observe these sources, right? So with future space observatories, in this plot, this is the same plot as before, but I just added some lines here to indicate the flux thresholds for some future or perspective space observatories. So we all know that gravitational waves are very efficient in probing mergers of black holes, and LISA would be fundamental to explore all this part of the parameter space shaded in blue. And as I will be saying in a few slides, LISA will be very, very important, especially in the high redshift universe and in the low mass regime, because it will be important to discriminate the seeding model. So if at high redshift we are mostly forming small seeds or high mass seeds. Instead, X-rays are very important to probe gas accretion onto black holes, and these three perspective space missions will be very important to study all this part of the parameter space shaded in red this time. And as you can see, it will be complementary to LISA, especially at the high mass regime, and X-ray missions will be very important to study the cosmic growth of black hole via gas accretion. So, as I was saying, LISA will be very important, especially in this part of the parameter space, so at low mass and high redshift. This plot was done assuming that at high redshift, so at redshift 20 to 30, only light seeds were formed. So only black holes that are descendants of the first POP3 stars, population 3 stars that were formed. So we don't expect these black holes to be much more massive than 1,000 solar masses. But the question is, what happens if we only form very massive black hole seeds, for example, through the direct collapse black hole scenario, also via whatever scenario that you want. If we only consider heavy seeds, so seeds of 10 to the 4, 10 to the 6 solar mass scale, you see that compared to the previous plot, the importance of mergers here strongly decreases, meaning that with LISA, we do expect a much lower merger rate at high redshift and low masses. So LISA will be very, very important to determine the main formation channel for black holes at redshift 20 or 30, because we do expect very different merger rates between the two different models. So, of course, the main growth channel is also related to the spin of black holes, because a stable gas accretion on a black hole is usually believed to lead to higher spin values of the black hole. Instead, if growth happens mostly via merger, we do expect lower spin values. So in this case, in this part of the parameter space, and also at high mass and high redshift, we do expect very large spin values. Instead, at high mass and low redshift and low mass and high redshift, we do expect lower spin values for black holes. So we actually tested our model at very low redshift. As you can see, this is the same plot that I was showing before, only limited to low redshift. So this is 1, and this is really the local universe. So to test our model, we used the data for 23 measures of AGNs in the local universe, and the data was taken from Vasudevan and Reynolds. This is a beautiful review, by the way. And so all these circles here are black holes for which the spin is measured. The larger is the circle, the higher is the spin value. And also, as you can see here, dashed border indicates that it's just a lower limit on the spin. So as you can see, with increasing black hole masses, so going to the right of this plot, we do expect a decreasing median spin parameter, and this is both, considering all data available here and only considering precise measurements, so discarding lower bounds. And this is what our model was expecting, because if you go at higher black hole masses, we do expect that we are reaching the part of the parameter space where growth is mostly via merger. So we do expect a lower spin parameter. And another prediction is that black holes in dwarfs are expected to be rapidly spinning. So in this parameter, in this range of the parameter space, like 10 to the 4, 10 to the 5 solar masses. So now I just want to shift a little topic, and I want to present you with a possibility that could change also significantly this picture. I wanted just to restart with a little chart to show the cosmic evolution of black holes from the Big Bang until now, about 13.7 billion years later. So we now know that the first supermassive black holes were already formed by 1 billion years after the Big Bang, and the seeds of the first supermassive black holes were formed here in the cosmic dark ages, redshift 20, 30. So what I'm going to describe now is a possible population of quasars that are still undetected, and this could have happened in the reionization era, so at redshift higher than 6. So all this started from the discovery a couple of years ago of the farthest lensed quasar ever found so far. This is a beautiful source that I will describe in more details now. It's a redshift 6.5, and it's an extremely magnified source, with a magnification factor of 51. So this is the preliminary observation that was done by Xiaoyi Fan and collaborator. And as you can see in this preliminary image by the LBT, the source appears to be unresolved. You can't really say that there is a double image, but it was for sure ultra luminous. This was at discovery the brightest source ever found in the universe, with a bolometric luminosity of 3 in 10 to the 48 per second and an estimated black hole mass of 5 billion solar masses. So this is the source that I'm talking about, and here there are reported other famous black holes, and the contour here shows the distribution of Sloan quasar at lower redshift. So what's the matter with this source? This is the spectrum that we took at the Keck Observatory a couple of years ago now. And this is a beautiful spectrum, but I want you to particularly focus in this part of the spectrum, which seems to be unremarkable, but it's very important for our purposes. So this is the Gunn-Peterson trough, where you don't expect light coming from sources at redshift higher than 6, because there is a lot of hydrogen and neutral hydrogen between us and the source, right? So here you can see some IgM spikes, but you can also see what seems to be some weak continuum emission here. So this is what led Xiaoyifan to ask for some HST data. So this is what we got for the source. It seems to be like some substructure here. It doesn't seem to be a single source, but you can see at least two components here. And also another possible component here that we call the G for the reason that you will understand now. So how do we understand what this component is? We can take a picture of the same part of the sky, but with a filter that is centered in the deepest part of the Gauss-Peterson trough. So you don't have IgM spikes there. And if you do that, you go from this image to this image. So the quasar completely disappears because it's a redshift higher than 6. And there's some remaining substructure here that we discovered to be the lens galaxy. So this is the best fit model. The lens galaxy is at redshift 6.51. Actually, the redshift measurement is very precise. And this is the lens galaxy, much closer than us, of course. In the fiducial model, we do expect 3 sources, but 2 of them are too close to each other, so we can't discern them. And the source is magnified by a factor of 51, and the maximum separation is about 0.2. So that means that it's basically very close to the HST resolution threshold. Also, the lens is peculiar because the stellar mass of the lens is quite small. So now that we know that the quasar is magnified by a factor of 51, we can understand what are the intrinsic properties of the source with a much more common luminosity of 5 in 10 to the 46 and a black hole mass of 500 million solar masses. So what do we do with this observation? We wanted to understand how likely is this combination and if there is a possibility that we are missing a lot of other sources like this. So we computed probabilities of magnification, and I will be describing this plot step by step now. On the x-axis, there is the log of the magnification up to 100. And here on the vertical axis, there is the log of the probability of having a magnification factor higher than a given value on the x. So this is our quasar, magnification 51. And to date, so also today, there is only this single quasar, redshift higher than 6, that is confirmed to be lensed out of 250, 300, I believe, at this point. So this is the observed frequency of this kind of sources. So just a little comment on the model. We use the, for the quasar luminosity function, we use the double power law, and the bright end is parameterized with the factor beta. So if you consider a shallow value of beta, 2.8, that's a very common one, this is the probability distribution that we expect with a probability of strong lensing with about 4%. Instead, if we choose a steeper value of the quasar luminosity function, 3.6, we expect this distribution of the probabilities of magnification. So it's a higher probability. But what matters in this plot is that independently on beta, on reasonable values of beta, of course, we do expect that there are many other sources that are lensed more than the single one that we discovered so far, right? So we're missing basically all these sources. So all these sources are what we call phantom quasars. So they are quasars that for some reason, lensed quasars at redshift higher than 6, that for some reason we are not observing. So why can't we detect them? There could be a selection bias in photometric surveys against lensed quasars, and also the separation between the images could be unresolved, so we can't just see that they are lensed. So why are we misclassifying the lensed quasar? So the first point that I just mentioned. Assume that this is a quasar. This is the best of my drawing abilities. And assume that you are doing a photometric survey of this quasar. So in order to pre-select this source as a quasar, you need to have a very large drop between the light of the quasar here before the Lyman alpha and after the Lyman alpha in the dropout band here. But the problem is that if you had a galaxy in the foreground, you can have also some light added in the dropout bands, and that could fool your selection criteria. We were lucky with this quasar because it's extremely magnified. So if this quasar was not magnified by a factor of 51, but was magnified by a lower factor, then, I was meaning to start this. We would probably not have selected this source as a quasar because the light of the quasar would have been more comparable to the light of the galaxy here. So high redshift lensed quasars are likely misclassified into low redshift galaxies exactly for this reason. The other possibility is that the separation could be unresolved. So, you know, if you look at a quasar, you want the definite proof that it's lensed, you need to see different images, right? But it's possible that we can't really observe them because they are too close. So on the horizontal axis here, you see the separation between images for quasars that are lensed, redshift higher than 6, so about 6.5. And this is the fraction with a separation that is higher than a specific value here in the x-axis. So this is a cumulative plot. This is the separation of our quasar, and this is the HST resolution limit. So what this is telling you is basically that about 15% of the quasars that are lensed at around this redshift could have a separation that is lower than the HST resolution threshold. So we can't, even if we detect it as a quasar, we can't really understand if it's a lensed quasar or not. So in the last couple of minutes, I just wanted to have a discussion about how many phantom quasars are out there. Here on the horizontal axis, you see the probability of strong lensing that just for easiness, I translated into values of the beta parameter. So from 2.8 to very, very steep values of 4.5. And this on the vertical axis is the undetected over the detected population of quasars, meaning a value of 1 means that the undetected population equals the detected population in number density. So assuming, for example, a number density of 1 gigaparsec per gigaparsec cube, that is the value of given by Chandra, for example, you can see that assuming a shallow value of beta, about 2.8, the values that I was discussing before, you see that the correction is very small, it's about 3%. So it means we're not missing so many quasars. But if you choose very steep values of the beta parameter, and this value was proposed by Kulkarni 2019, so it's not so far-fetched, then we are missing out a huge population of quasars, of lensed quasar at high redshift, up to 12 times higher than the known population so far. So this is the reason why I was telling you before that if we have to add many many quasars that are not recognized as quasars right now, or because they are maybe misclassified by lower redshift galaxies, then our quasar luminosity function could change, and also the picture that I was describing you before about the growth of black holes across cosmic time could also significantly change. So I will give you just a final summary. So we saw in the first part that growth by accretion is dominant in a large part of the parameter space, especially in the high redshift and in the high mass range here, still considering a mix of high mass and light black hole seeding at higher redshift. And also the growth by mergers is dominant for small black holes at high redshift and large black holes at lower redshift. And as I was saying, Lynx, Athena, Axis, and Lisa will be fundamental to explore this parameter space. And especially Lisa will be fundamental to explore this part of the parameter space and really understand what is the main seeding model at higher redshift. And I concluded the talk by talking about the possible presence of additional undetected population of quasars at higher redshift that could significantly change this view. And actually, we're doing a project now with a student that might be listening now. So, ciao, Lucia, if you're listening. We are trying to use Chandra data. She's Lucia Gordon. She's an exceptional student, an undergrad at Harvard. And we are trying to use Chandra data right now to try and understand if we can look for, if we can find more quasars like this at redshift higher than 6. So thank you for your attention, and I'll take your questions.
All right, thank you, Fabio. If anybody has any questions, you can raise your hand in the participants window, or you can send us a message via the chat. Likewise, there's a Slack channel that you can use that Rutu is monitoring. I see one from Magdalena.
Yeah, hi, thanks for the talk. I'm curious, when you talk about mergers between massive, so mergers, growth through mergers, do you have an idea of the mass ratios between the mergers? So say the most massive black holes grow via mergers at low redshift, right? Or was it the other way around? Either or. Do they grow by lots of mergers with smaller black holes or fewer mergers with massive black holes? What are the ratios?
Yeah, we haven't explored the ratios directly in our model, but I can tell you that in this part of the parameter space, at least we saw a lot of black holes of minor mergers, so small black holes that are merging with each other. And I just wanted to mention also this regarding your question. So the reason why we see enhanced importance of mergers here at low mass and high redshift in the light seed model only with respect to the heavy seed formation model is that in the light seed only, we have a lot of black holes here that are formed at the lower mass scale, so the density is very high. So that's the reason why we have a surge of mergers here. Instead, if you form only heavy seeds, the number density of heavy seeds is much lower. Could be one heavy seeds out of 100 light seeds, or even less than that. And that is the main reason why we're not observing many heavy seeds right here. So at least in this part of the parameter space, I can tell you for sure that we are observing a lot of black hole, a lot of small black holes that are merging with each other, as opposed to a large black holes that are merging with each other, which would be the case here at lower redshift and higher mass.
And can I follow up?
Yeah.
So do you make predictions for Lisa? Because that will probably change what kind of merger events they would observe. Right?
Yes, I am working right now with some collaborators on using exactly this model to make predictions for Lisa mergers. Yes, and as I was saying, especially this part of the parameter space will be very important because we do expect merger rates that are different by factors, even 20 or so. So I can follow up with you. I can send you some numbers later if you are interested in this, because we are working on this right now.
Yeah, thank you.
Mm-hmm.
All right, we have time for, I think, at least one more question.
Also on the pizza.
Okay, I don't see any more in the chat, and I don't see any raised hands. So there are no further questions, then we can thank Fabio.
Thank you.
And of course, if you want to contact him for further information, his email is in the directory.
Yeah, thank you.
All right. I guess we are moving on to our second talk of the day. Our second talk today actually has two speakers, also at the CFA. So all our speakers today are at the CFA, which is why we didn't have speaker schedules, but feel free to contact any of them if you'd like to speak further. So our first speaker for our second talk is Dr. Kimberly Arcand, and actually fairly newly doctored. She recently finished her PhD, so congratulations on that. So Dr. Kimberly Arcand is an expert in astronomy visualization and has been a pioneer in 3D printing and extended reality applications in this field. So Kim began her career in molecular biology and public health before moving to Chandra and the CFA in 1998. In addition to being an award-winning producer and director, she is an expert in studying the perception and comprehension of high-energy data visualization across the novice expert spectrum. Kim has co-written 7 popular science books, including her first 2 children's books that came out this year. Our second speaker for our second talk is Kelly T.S. Williamson. She's a web developer and social media lead for Chandra. Kelly began her career in veterinary biology and political science before becoming an award-winning web developer and content producer for the Hubble Space Telescope at the Office of Public Outreach at STSCI. With over 20 years of experience in science communications, Kelly has a passion for engaging people of diverse knowledge levels and backgrounds with the goal of increasing scientific literacy in society. So Kim, Kelly, please take it away.
Thank you, Ritu. Let me just get my slideshow going. So I see the numbers are dropping a little. Everybody came to the first black hole talk and people are starting to scatter. However, I will just say that if you think black holes don't relate to this second talk, you are wrong. Black holes are actually one of the most popular things on social media when it comes to astronomy. So if you're interested in black holes, you should stick around for this. So I'm just going to go really quickly through kind of an overview. Actually, I'd love for you to use like the raise hand feature or the yes feature or whatever. Who here actually does already tweet, Instagram, or perhaps TikTok? Just curious, raise hands. I see Jonathan McDowell. Yes, I know you tweet. Yes, anyone else? All right. A few, a bunch. Okay, I see more and more. Awesome. Just curious, any of those people venturing into TikTok yet? I see a lot of head shaking. No. Okay, me either. I can't get into TikTok, though my kids do love it. So, okay, the point of the talk today is just kind of give you a little bit of background on how we use social media channels to eventually talk about Chandra science. We've had definitely some successes over the past few years. We've been doing social media for Chandra for a long time, pretty much since Twitter started. And we have developed very particular like data-driven strategies because we're really interested in understanding who our audience is and how to best engage them. And engagement is a topic that you'll see come up more and more. It's important to know your metrics in general, and absolutely paying attention to the number of followers you have is important, but even more importantly is understanding which of those users are engaging with you. So who is leaving a comment, who is liking, who is retweeting, who is whatever. Those engagement levels really do tell you a lot about the content that you're offering. And then the second half of the talk, or maybe the bottom third of the talk really, will be more specific guidance for scientists who are interested in either starting out on social media or just want a few best practices and some tips and tricks to learn. So here are our latest social media stats as of yesterday. YouTube is our most prolific platform with over 6 million video views. We have 30,000 something subscribers, which is really nice because even if you post a short esoteric video, you're going to get lots of eyeballs on it. Instagram has been our sort of dark horse. It started out a little bit slow, but now we are almost at 1 million followers. So if you have like 1,000 friends and family that you all know and you want to just tell them to hurry up and go follow us so we can get to the 1 million mark, that would be really cool. Instagram has been an awful lot of fun to work on, and to see the follower response to the post has also been very, very engaging. We now have more followers than NASA's APOD on Instagram, which is truly shocking to me, in the best way. Twitter is another one. We've had this presence for a long time, and we were kind of stuck at the same follower count for a long time, but we've just started seeing more growth there as well. We're up to 214,000 followers. And Facebook, which is my personal least favorite platform and the one that I spend the least amount of time on personally, has 321,000 followers and still is a very useful type of social media. Our social media followers and community, if you will, they are part of our larger digital portfolio. And I'm just offering a very brief glimpse here of some of those other aspects of our digital portfolio. The Chandler Public website specifically is pretty popularly trafficked, I think, especially considering this is a 21-year-old high energy astrophysics mission. Some of the topics are not necessarily going to be the most approachable, but yet we do attract a pretty wide variety of audience members and some pretty heavy hitting traffic to the website still. After 20 years, I feel like that's an accomplishment in and of itself. Some interesting spikes that might be useful for you to know. The first one, of course, going back to black holes, April 19th, we had a 20 million spike for the EHT black hole result that Chandler had a small part on. And that was overwhelming. The community involvement there was incredible. And just the response overall to that image, of course, was amazing. But the follow-up resources that Chandler provided on basic primers on black holes, videos with background on black holes, I think really did help the community, especially people who are discovering a love of black holes for the first time. In October 19th, after the 20th anniversary, we had released a Cassiopeia A time-lapse movie that was, I think, quite beautiful. But it didn't get very popular in the month that it was released, which was, I believe, August, around like August 23rd. Instead, it got sort of like a slow burn. And by October, it had grown to be a huge result. It got picked up on some large news venues, and they will remain nameless, but that really helped, I think, make this one of our most popular ones ever, which was also really lovely. I should say the EHT result was our biggest surge ever. And then this year, which I had expected, to be honest, to be a smaller year, just post 20th anniversary, but also with something called the pandemic going on, I hadn't really known what to expect. But in June, we had a pretty big surge of 16 million for that month. And a lot of the traffic did not go to a press release, which is what our usual purview tends to be. Instead, it went to our at-home activities that NASA and Smithsonian and other organizations had been promoting pretty heavily throughout the spring. Quite a large chunk of the spring actually showed social media and web stats growth because more people were at home, of course, and they were really looking for and trying to find high quality activities to do at home, whether by themselves or with family. And then finally, another surprise, September 20th, a 14 million mini surge on the data sonification release. I was very pleasantly surprised on. It was a project that we had been doing specifically for people who are blind and visually impaired with the hopes that other people would enjoy it as well. And it turned out to be so. And having that response to that material was truly a pleasure to hear or see. Also, we have podcasts that have been very popular for a while. Those are still to this day our #1 download. We actually just had an augmented reality app that was featured in Apple's App Store, which was a surprise bonus and causes huge surges of traffic as well. And we have additional like image feeds and blogs as well. So our goals is that we are, of course, public reaching. We tend to be data driven and user centric. Inclusivity is a true must for us. We are aligned to NASA and Smithsonian goals. We, of course, must adhere to government regulations and mandates. For example, there was a congressional mandate given at the end of 2018 to remove all flash files from government websites by the end of 2019, I believe was the deadline. But we did it with less than a year. So we were a few months actually ahead of that deadline. But it's really important to us to be responsive to not only our funders, but also US government at large. We also very particularly follow the protocols for ADA and 508 accessibility guidelines. Universal design is our goal. We can't always do it with everything, but that is definitely what we prefer to do. Funding for our social media comes mostly from the NASA Chandler contract, but we also do get a tiny bit of funding from NASA's Universe of Learning for that as well. We had 26 Chandler news releases in 2019. We'll probably have a similar amount in 2020. NASA Twitter account promoted about 65% of those. Anytime NASA promotes on their Twitter, which has over 40-something million followers, and Kelly will talk about that in a minute, we do tend to get a pretty good kickback from that. The idea of us sharing our science, though, this is obviously an important thing to do for many reasons. It's about reaching people where they are versus making them just come to you to come to your website, right? Visit chandler.sid.edu. We say it a lot, but we don't want to always have people to go here to see stuff. We want to be able to reach them on these other platforms that they're experiencing throughout the day. Our reading levels have to be low enough that the majority of people in the country and beyond can be able to understand them. All our materials are reviewed in different ways, either through NASA Communications reviews or NASA's product reviews. We are on a lot of different committees and working groups to make sure we're in sync with the rest of the missions and the larger groups at NASA and Smithsonian at large. So we have been able to see significant growth across all of our platforms, particularly since 2017. Kelly is responsible for a majority of that growth. Our number of users, our subscribers, our reach, our engagement levels, all of that have gone up. And as I mentioned, YouTube and Instagram particularly are our probably favorite platforms and where we're seeing the most growth. We do use a pretty rigorous system of metrics to be able to keep track of everything through multiple means, Hootsuite internal metrics, Google Analytics. We study the best times to post things, and we also pay attention to which groups are looking when. We have, for example, a pretty large population of people in India who follow us on, say, Twitter. So we'll pay attention to their time zones to make sure we're posting material that is useful for everyone. We try to engage users where they are. So we make sure that we're functioning at a level that is the most useful to our customer base, if you will. And one key thing to take away is that there is no one size fits all in social media. Every platform is very individualistic. So you cannot apply the exact same content across each one and hope you'll get the same results. It really does not work well. Instagram has a very different type of community than Twitter, and what is highly successful on Twitter may not work on Facebook. And not to mention, all the kids are on TikTok these days, but we're not yet. So I'm going to pass this over to Kelly for some examples and case studies.
Hello, everyone. A couple of the case studies I'd like to go through are what typically drives our traffic and where typically we're seeing our successes. And one of our main drivers, of course, is news traffic. And social media properties love to have as it happens updates. It's one of the little drugs in social media, so to speak, is that new is new. And with a news release, it could be a new image, it could be new science implications. Anything really shiny tends to get a lot of coverage for us traffic-wise, both to the website and to the social platforms. NASA is a star. Absolutely a star. We're looking at, over 40 million subscribers there, which is more than Elon Musk has. It's more than the BBC World News. And believe it or not, it's like double what Snoop Dogg has. So, I mean, when NASA puts something out on social media, it truly has a lot of weight behind it. A lot of engagement can come from it, and a lot of reach can come from it. So when they repost us, we do really well with traffic. One of our it was actually crazy to Kim and I at the time, was the EHT result and how people really enjoyed that. And Joey Nielsen was able to do a Q&A for us online. He's on Twitter quite prolifically. And the audience loved it. They were very happy to engage with someone who could answer their questions at their level without sort of any condescension. I mean, we had people who were asking for the math, and then we had people who were asking, well, truly, what is a black hole? And Joey was really good at kind of making all of that work. And our community really, really enjoyed it. So that's something we're hoping to do more of in the future, but it's kind of a touchy thing as to when, sort of a result comes out and how we want to discuss that with folks. Another thing that we do is it's hard for the general public to understand that astrophysics is more than just visible light, pretty pictures, nothing else to it. And so we try to share different content, multi-wavelength content, to help put that into perspective. For a lot of our followers sometimes, or for a lot of our people who see our posts for the first time, they actually may not have even been taught about the electromagnetic spectrum in school. So when you can explain how X-rays relate to visible light, relate to what we can see and what we can't see, they're often fascinated, and it's truly engaging for a large portion of the social media audience. Another way we typically get a lot of traffic is through our World US Days and Holidays. And these hashtags are very popular on a given day, so they're seen by a wide variety of folks, maybe a group of folks who don't necessarily look at science online or other things, and it kind of exposes them to that. And it's a great way to reach new audiences and possibly convert them to being your followers later on and visiting your website and, expanding their minds. Shark Week was a wonderful campaign we did a couple of years back. It's no longer okay to do this, which is kind of sad, but we had a lot of fun. And again, it really had great reach because it went way beyond the scientific community and kind of got folks interested in space. NASA posted this animation that we did a few days later, and it did great on a bunch of different platforms, including their Tumblr, which is one of their larger property, or one of their faster growing properties these days. Mission specific content. So I know you all probably, if you've gone to our Twitter page, you'll see the right now or today. It's a way of taking what Chandra is doing on a daily basis, so the in the now as it happens, and wrapping it in something that folks can engage with on different levels. And if that's science, great. If that's just, ooh, look at that pretty picture, that's also good. And they can admire it for many different reasons: aesthetics, science, technology, and by the same token, we're getting Chandra out in front of them and saying, like, yep, Chandra is still doing science. And that was a big thing at the beginning of the pandemic. We got a bunch of questions from folks. They had no idea that we were actually still working and still doing everything that we had on the schedule. 4th of July, so that's again, that's another holiday that's sort of wider. So even grandmom, if she looks on Facebook on the 4th of July, may get exposed to this and may see a pretty picture, and then we may convert her to come and take a look at different posts and perhaps come up with some questions and that she can answer for herself by looking at the materials. Instagram is just the star right now. About 20 minutes before this talk, I noticed we were less than 200 people from hitting 1 million. I was like, can we have this talk at about 4 o'clock, please? That'd be better for me. But the Instagram folks are very visual, as you might guess. But one of the other things is they typically ask more questions than any of the other platforms. They're extremely engaged. They're often hundreds of comments on every single post we put on Instagram. So it's a different type of experience, because it really is the visuals that catch the eye there, and the caption is sort of kind of buried in things unless they're really looking for it. And how many of these captions actually get read all the way to the very end is really interesting and different than a lot of other folks who have properties on Instagram. So YouTube, of course, all of our videos on YouTube get watched more often in serial. So somebody sits down and watches, maybe 50 Chandra videos in a row, but it's one of our properties that it's different, and we're looking to expand it possibly with doing some more full production things. Anyone can watch YouTube now. I mean, almost every smart television has the capability for you to sit in your easy chair and just watch something. So that's an entirely different audience, and one we're looking forward to exploring a little bit. So now I'm going to pass it back to Kim to talk about information for your own social media.
Thank you, Kelly. I didn't know that we only had a couple hundred to go. So now everybody on this call, I'm sure you have at least like 5 or 10 friends you can convince to go follow us on Instagram. So one of the main things that I would recommend if you're just starting out, or even if you have had social media for a while, is to make sure that you have a disclaimer in your bio that opinions are my own, or not my employer, or whatever. That's really important. There's a lot of concern, especially if you're working on the Smithsonian side, about not combining work and non-work information, particularly in a timeline. So, for example, their point is that you cannot wear 2 hats at once. And if you're going to be very prolific in medium, say Twitter, for work type of topics, and then also very prolific for your own personal topics, they actually do recommend separating accounts. Though I know logistically that is difficult, but that's just sort of the disclaimers that we must start with. We have been obviously paying attention to world events this year. There's been a lot of really serious and heavy stuff that's been happening around us, and you cannot be tone deaf in a very public way on a very heavily trafficked platform and think you'll be okay. So being able to respond in real time to whatever's going on in the world, be it civil unrest, be it issues around voting, be it a little thing called the pandemic, whatever it might be, it really is important to pay attention and to respond in kind. So one of the things that we did this year that Kelly has been excellent at is being a calming distraction as far as what Chandra's output is like on social media. And I think that really has worked, and we've seen pretty lovely interaction increases and follower increases over that time. To be a little bit more respectful, we have done things like reduced emoji use. We've avoided those like fun or sillier hashtags or posts or topics. And then we also, during the height of some of the more difficult times, we actually decreased frequency of posts out of respect. And this was all done in consideration with others at NASA headquarters as well. So we're not doing this completely on our own, but also making sure that we're following the lead of our funders. But it's really important to notice that doing all of those above things did not impact long-term growth or reach in a negative way. Instead, we've only seen positives. So we're very happy to have seen that. So tone, as I mentioned, it's really important, right? You don't want to be talking about supernovas when there's something going on Earth where there's an explosion happening, right? That you just have to be careful. There are these sort of nuances to this type of material that not everybody is going to get it right all the time. Of course, people make mistakes. We're all just human. But it is useful to be able to try to read the room. And Kelly and I, at some of the peaks of some of the difficulties going on, were just contact each other via text or email in the morning, like, how are things looking to you today? I mean, just it really is a matter of understanding and also getting other people's opinions sometimes. But silence can be golden in this case. And here's a gratuitous golden retriever picture. You're welcome. So if you have a scoop, one important thing to realize is that you cannot use your internal privilege to be able to share that information via a public social media channel. Please do check with your organization's policies. If they do not have official or formal policies, likely they have a policy in the works. So please do check with your organization and your colleagues and supervisors to be able to be sure that you are not misrepresenting something or upsetting a group or what have you. But if you know of something that's going on, please do think very carefully before you post that on social media in a public way. Volunteers, we're always looking for volunteers. As Kelly mentioned, the interaction with Joey Nielsen was really successful and everybody enjoyed it, and we enjoyed it, to be honest. So if you have a press release coming up and you also have a fun penchant for doing social media, please do let us know that you would like to be involved in something more. And as time allows, of course, we try to encourage that. So Kelly, do you want to pick back up? Or did you want me to keep going? I don't know if we actually had a hard stop, but go right ahead. I'm getting tired of talking.
Well, I guess I hadn't planned on talking about this,
Oh,
but what the heck?
Okay.
So content is obviously king when you're going to post social media, if you're looking to get reach or if you're looking for engagement. And things that are pretty and shiny do really well. Videos that are well explained or images that are well explained also do pretty well. You cannot be overrated to be authentic, though. Coming across with a voice, a very corporate voice or a very professional voice, will get seen through very quickly by folks. They want authentic engagement. Also, in your own social media, be sure how you want your voice to be heard years and years down the road, because things will be cached, things can be recovered. Determine what your voice really should be, and that authentic engagement can't be oversold, really. So if you're new to social media and you don't know how to get started, of course, this talk will be available later with this list, but it's follow scientists inside and outside your circle. Not always astrophysicists. Possibly, do you have an interest in, I don't know, zoology? Follow somebody in that scope. It's broadening your scope will get different people to see your content and different people interested, more people interested. Follow journals that you're interested in, sure, but a good mix will get you farther in that regard, and it will keep you centric to what you're interested about talking about, whether that, is all astrophysics all the time, or possibly bringing in your hobbies and that sort of thing, which, would also bring in the authenticity. Are these folks talking to 3 or 4 people, or are they talking to a bunch of people? Keep an eye out for that sort of thing, and try to engage those conversations as well. And always be respectful and inclusive of others. Social media can be a really bad lunch table to sit at if you mess up. So if you don't have anything nice to say, don't say anything at all, is what grandmom used to say. So I think that that's probably a pretty good way to go. Do we have any questions?
Have we wowed you with our social media knowledge? I feel like we must have.
Thank you, Kim, Kelly. That was wonderful.
Thanks.
As usual, for questions, please either raise your hand or put it in the chat. There's been a long discussion going on in the chat.
Oh, wonderful. So yeah, I couldn't see while I was sharing my screen, but Dan Schwartz, I'm confused by what seems to be surprised that Chandra is still of interest after 21 years. No, that's not at all what I meant. What I meant is that as a 20-year mission, Twitter wasn't even around when Chandra was being launched, right? And it did not have the excitement of launch, like Mars 2020 rover landing soon, like is a huge social media push, right? So there is a natural, very sort of excitement around that because the mission is just happening. There's like bigger push from headquarters because that is so, right? So it's just the fact that we had to build our audience in a very different way than having that dramatic launch on a foreign planet kind of thing. So no, I was not insulting Chandra. I love Chandra. I've worked for it forever. Let's see. No, this is not a dig at XMM or New Star. I'm not sure I can read that fast enough. Twitter had an exchange with Ariana Grande. Yes, actually, that was a very popular exchange. The song that Ariana Grande had written about NASA, NASA to be precise, was a huge hit. And so the playback between Ariana and NASA on social channels was huge. And it might have been their most popular tweet exchange of the year. I think that was that last year? So yeah, it can be great to bring in new people by trying some of those different things. Today, for example, there was an exchange with SoundCloud because NASA released a new SoundCloud of sort of like eerie sounds from a number of its missions. And there were 4 Chandra sounds on that, by the way, the Data Sonification that I mentioned earlier, which as I last saw were #1 on the list. I hope they're still #1 because that was really cool to see. But there was a really nice exchange between NASA and SoundCloud. To me, it was a little bit younger, but I think that's probably going to attract some people, perhaps repel others, but there's always this sort of push and pull of experimentation on social media, especially when you're trying to reach new audiences, as both Megan and Peter seem to be talking about. So let's see, where else? Any other questions? I think that's the main ones.
There was a
Thanks.
question about whether the slides will be available somewhere after the talk. The talk itself will be available on YouTube, but I'll let you answer about the slides.
I don't usually make my slides available, to be honest, but if there's a talk that's already recorded, but if somebody needs something specific, please do contact me. Sure. Hopefully that helps. Any other questions I missed? I was trying to do them fast because I know we're all hungry for like lunch if we didn't actually eat pizza yet, which I have not.
Oh, it looks like Jonathan has a slightly different goal than getting more users and more engagement. And John, that's perfectly fine. And everybody has their own style on social media. Unfortunately, we have to actually be held up to the NASA metrics discussion about our followers. But yes, there are plenty of people who have small communities and have really, really deep conversations on a regular, and that's perfectly
right. And that's the distinction, right, with not being a mission account, but being,
yes.
you know, you as a scientist. You don't, you know, your goal should be, you know, you just talked about authenticity, right?
Yes.
And it's better to be authentic than to try and mold yourself to be popular.
Absolutely.
Yes. Although, Jonathan, I'm pretty sure you are popular on Twitter. So
Yeah, but you know, okay, so I have 38K followers, but if I
only 38,000. Not that I know exactly the number. No, you do very well. You do very well on Twitter because you have a very specific style, and it is very useful information that you don't get anywhere else. So like you bring something new to the table.
Right, original content and
yes.
take.
Exactly. And that's what we try to do as well. We try to provide original content and try to hit a broad swath for the mission. As you say, it is a different goal.
Yeah. And
But
really
being a voice
easy.
is very useful.
Twitter's really easy starting out because it's like low effort if you're a busy person, whereas like Instagram is like, oh, I have to make a picture.
I actually find Instagram easier, but that's because I'm doing visual stuff all the time. So
anyway, thanks for the talk.
You're welcome. And thank you very much for all the questions in the chat on the chat box. It's really nice to see.
Yeah, thanks everybody. And thank you for sticking around, even though we're a little past time. So Kim, I have to say that we actually had more people on today than we've had at any of the other talks.
Oh, so maybe social media is popular, or maybe it was the black hole talk. I'm pretty sure it was the black hole talk, but that's okay.
Always black holes.
Everyone loves black holes. It's terrible.
We've got black holes in both talks, so it must be that.
Yeah. Thanks so much for having us, though.
Thank you.
Kelly, thank you, Fabio.
Thanks.
Talks will be posted on YouTube. I know some people were asking.